everybody. My name is Miss Seachek, for those of you that don't know me, and we're going to start talking today about different types of polyhedra and beginning to name some three-dimensional figures. Now, as a warm-up, what I want you guys to do is to take a moment to pause the video and write down at the top in the warm-up section 4 different real-life objects that possibly you're even just seeing right in front of you right now that are examples of three-dimensional shapes, and if you know them, what kind of shape it three-dimensional wise it's modeling. So name an example and then what kind of shape it is modeling. You could do that right now. Now, there are a lot of different examples that you could have named, but a couple of them maybe you talked about a Kleenex box. That's a great example of what we would call a rectangular prism. That's perfectly okay. Another thing you might have thought of is possibly a roll of toilet paper. And that would be a great example of a cylinder. And a lot of other cylinders maybe you came up with as well, kind of something like that. But a cylinder works for a lot of those. Maybe you thought of a baseball or a sphere. That's another great example of a three-dimensional figure. And last but not least, maybe you thought of a funnel. That would be an example of a cone. Just a couple examples there, but obviously you're free to have others as well. Now, as you look down below here, what you're going to see is a little bit of discovery. And we have 3 examples here of things that are considered polyhedron or polyhedra, which are plural polyhedron, and we have some things that are considered not polyhedra. For examples D, E, and F. So take a moment yourself and again, just write down what you think. What are some differences between the three-dimensional shapes on the left that are polyhedra and the ones that are on the right, D, E, and F, that are not polyhedra? So what are just some observations that you have about them? Well, again, some open choice here. And again, you might have had different answers than I did, but what you could notice here is that with our polyhedra, one thing you are going to notice is that the faces are polygons. There are no circles involved on the left-hand side, right, with examples A, B, and E. On the other hand, however, in the not polyhedra, what you may have noticed is that these do in fact have a circular face. So notice in the faces there, right, in B and E especially, you can see those look like those are going to be circular faces. So that's, instead of polygons, they are circular. Now, out of our examples up above, A, B, C, D, E, and F, which one would we consider prisms? Well, our prisms are going to be ones like example A and example B. Those are going to be examples of our prisms, while our pyramid is going to be something like example C. So as we start filling in the blanks down here to talk about a little bit of the differences between prisms and pyramid, as well as some vocabulary, what you're going to notice is that in our prisms, so like examples A and B, all of the prisms have faces that are in fact polygons. All those faces are polygons. Now, the edge is a line segment where the faces intersect. So if you notice, I'm going to use my writing tool here. See the edges on our prism, that example like here, maybe here we notice, and that's where these faces are intersecting. So we have a lot of different examples of edges in there, and again, that's going to be where the faces intersect. Now, a prism has 2 congruent faces, right? And those faces that contain those parallel planes, those are called our bases. Now, in example A, Officially, you can kind of consider a lot of these opposite sides, if you will, of our prism the bases. Maybe you think those two are the bases. Officially, though, you could also call, for instance, these two the bases, these opposite parallel sides. Now, in example B, notice it's a little more straightforward which ones have to be our bases, the parallel opposite sides. Those have to be here, and this red here, and then back over here as well. You'll notice those have to be the bases because they're the only ones that are parallel to each other in that particular picture. Okay, so again, two of those. Now our pyramids, so if we look over at example C, the pyramids have just one base. Okay, they only have one base. So unlike our prisms, they will only have one base. And the pyramid has all faces intersect at a point, and this point is called the vertex. So in example C, our point up here is that vertex up top. So again, they intersect at a point called a vertex. Now in a prism, all of the lateral faces are parallelograms. All going to be considered parallelogram. All those lateral faces. So basically anything that is not considered our base are going to be our lateral faces, and they're always going to be parallelograms. They're usually going to be either rectangles or they're going to be squares, depending. In a pyramid, all the lateral faces in a pyramid have to be triangles. So if we look again up at the examples above, for A and B, again, all of our lateral sides here are some sort of rectangle or square. Again, they are parallelograms, while in our pyramid example here, I'm going to erase this space, we can see this a little better. These are all going to have triangular lateral faces. Again, they're all going to be triangles because the base is some other polygon shape. All right, last but not least, in a regular prism, the bases are going to be any regular polygon. Any regular polygon. Now you're probably asking, what exactly does that mean? Well, the choices are kind of endless because officially it could be square, maybe it's going to be rectangles, maybe pentagons, hexagons, octagons, heptagons, you get the idea, right? Etc., etc. Now, our prisms and pyramids are named by their base. Okay, so we identify, is it a prism or is it a pyramid? And the type is going to be based on the base it has. So for instance, in number 4, notice from up above, we have these rectangular bases, and this is a prism. So we would call this a rectangular prism. That would be example A. Example B, on the other hand, is also a prism, but notice our bases have 5 sides, so this would be a pentagonal prism. This pentagonal prism. Last but not least, example C, we said is a pyramid. Now notice on this particular pyramid, the base, similar to the base of our last prism, has 5 sides. It's going to also be a pentagon. So we would call this one a pentagonal. This time it's a pyramid. Now, as we flip over to the back side then, and we start naming these solids as well, first thing we are going to do is take a moment to try and name the bases for A, B, and C, and then D, and then we will work on naming them. So take a moment on your own, and for A, B, C, and D, take a minute to pause the video and try naming the bases that you think each of those examples are. Well, to check yourself, our bases here, the first one, we have a triangle base. In each of that example, notice it was the same figure, just rotated to give you a better view. So we had a triangular base there. The next one, our base was a pentagon. In the next example, our base is a little hard to tell, but you could have called it a parallelogram. You could have called it a square, possibly. Probably the best name here is a rectangle, since they're not giving us a lot of information if the sides are congruent or not. And then last but not least, in example D, our best bet here is this one. It's going to be considered a rectangle-shaped base. Now, as for the name of these shapes, again, take a moment to pause the video and decide what would be the best name. Try out and rotate, or the names for those rotated triangles, and then example B, C, and D as well. Well, to check your work, all right, for each of these, make sure you correct them if you need to. The first one is going to be considered our triangular prisms. Our second one, again, we have that pentagon base, so it's a pentagonal prism. Example 3 is going to be our example of a pyramid. And again, depending on what you call the base, either a square or a rectangle, you could either call it a square or a rectangular pyramid this time, since we only have one base. And then last but not least, our final example is going to be a rectangular prism. All right, finally down here we have some three-dimensional objects by real life. Now you hopefully are able to identify pretty quickly what A and B are. Either pyramid or prism, right? But again, we want to be specific in what type of base they have. So for this first one, we're going to call this one a rectangular prism. And then in example B, again, we don't have a great amount of information to say if this is officially a square or a rectangle. So to be safe, we're going to call it a rectangular pyramid. And if you know that your base has 4 congruent sides, you could specifically call it a square. Now this last part is kind of up to you, all right? But again, take a moment to write down your very own definition of what is a difference between a pyramid and a prism, and take a moment to maybe tell someone at your house or text a friend, maybe someone else in your geometry class, and let them know what is the difference in your own words between a pyramid and a prism. Now to wrap this up a little bit, just in closure, again, our biggest difference between a pyramid and a prism, well, a pyramid, pyramids have one base, and all the lateral bases are triangles, while prisms have 2 bases, and all the lateral bases are polyhedra. Okay. So in case you didn't get that down, right, make sure you have at least that example. Of course, there are other things, but those are the main things you should know after today about our parallelograms and our pyramids. Last but not least, at the bottom of the page, you're going to notice that give you a little bit of extra information, not stuff you have to know, but of course it's always great to know extra information and see how cool geometry is in real life. And notice we have this term down here, regular polyhedron. We talked a lot last unit about what the term regular means. All the sides and all the angles are congruent in size. So in this case, these have the shapes, all their faces are going to be the exact same congruent shape. So we have some different faces, and you guys have probably seen these before, you know, a tetrahedron and a hexahedron, you know, sometimes we call that a cube, but all those same size sides all around those faces, everything is the same. So there's some cool examples down there for you guys to look at. All right, good luck with the practice, and thanks for listening.